Hello everyone. In this unit we're going to talk about specific heat and heat. So last time we were looking at internal energy and we saw that the internal energy of a substance is directly related to its temperature. And that's true in a gas because in a gas the particles don't have forces of attraction that hold them together and give them lots of potential energy interactions. That's not so true for liquids and solids. It's quite a bit more complex for liquids and solids. So rather than focus on the total internal energy of a liquid or solid, what we're going to do is we are going to look at the amount of energy that something gains or loses when it goes through a temperature change. So if something gets warmer, that means it's got to gain energy, and so it's absorbing energy. When something cools down, it's got to get rid of energy, so it's releasing energy. And the amount of energy gained or lost is called heat. So heat is not a total amount of energy, but rather an amount of energy gained or lost when something goes through a temperature change. We can measure heat with a variety of different units. One of the common ones is the kilocalorie. A kilocalorie is the amount of energy that 1 kilogram of water gains or loses when it's heated or cooled by 1 degree Celsius. So if 1 kilogram of water warms up by 1 degree Celsius, it needs to absorb 1 kilocalorie of energy. If it cools down by 1 degree Celsius, it needs to release 1 kilocalorie of energy. We use kilocalories to measure the energy content of food, so we are lazy and shorten kilocalorie to calorie with a capital C. That's why it's always written with that capital C. That actually means not. So when you see a serving size of Pepsi is 150 calories with the capital C, that's actually 150,000 calories. It's 150 kilocalories. So that's quite a bit of energy actually. This leads us to specific heat because this is different for different things. You'll notice I said a kilocalorie heated 1 kilogram of water by 1 degree Celsius. But not all substances go through the same temperature change when they get the same amount of energy, which you saw in lab. When you heated the water, it heated up quite a bit slower than the vegetable oil, and that's because vegetable oil has a lower specific heat. That means it's got a lesser ability to store energy, or it takes less energy to make it go through a temperature change. So the amount of energy required to heat 1 kilogram of a substance by 1 degree Celsius is called its specific heat, and it's different for different substances because there's different molecular interactions going on that make up that substance. So if a substance has a high specific heat, more energy is required to change its temperature. A lower specific heat, less energy is required to change its temperature. Water has one of the highest specific heats of any substance. It's got a very high specific heat. So we use specific heat, mass, and change in temperature to actually calculate the amount of heat energy gained or lost by a substance. Heat energy is denoted with a Q. Mass is M, specific heat is a little c, and the change in temperature is delta T. Of course, we know that delta T, change in temperature, is always the final temperature minus the initial temperature. So if you see that, okay, that means if something gets cooler, this is actually going to be negative. That's okay. That just means it's losing heat, not gaining heat. So the equation we use is Q equals M times C times delta T. M has units of grams or kilograms, C has units of calories or kilocalories, and delta T is change in temperature, degrees Celsius or Kelvin. Since a change of 1 degree Celsius is the same as a change of 1 Kelvin, those two units are equivalent. Now, like I said earlier, if the delta T is negative, it just indicates that energy is flowing out of the substance, and you're going to calculate a negative Q. That's okay.